Okay, so next we get into the second law of thermodynamics, and it's really broken down into this simple formula, which is saying that the total change in entropy is going to be equal to the sum of the change in entropy of our system plus the change in entropy of our surroundings. And since we're using this for spontaneous processes, which are again irreversible and natural, so all real processes are spontaneous processes, so therefore all real processes are irreversible, then the change in entropy, the total change in entropy, is greater than zero. So that means that for any real process that is spontaneous and irreversible, it's going to increase in entropy. So here we have a practice problem, which is saying that gallium freezes at 29.8 degrees Celsius with a molar enthalpy of fusion, which is delta HF, is equal to 5.59 kilojoules per mole. When gallium solidifies, is delta S greater than zero or less than zero? And the next part is going to tell us to find delta S when 60 grams of gallium solidifies at the given freezing point. Okay, so let's get into this first part. When gallium solidifies, is delta S greater than zero or less than zero? Let's think about that. What is the definition of a solid? Well, at the molecular level, sorry, I can't speak today, we know that the atoms or molecules, they're going to be very tightly knit together. And they're going to be vibrating at a certain frequency and all the like. We'll get into molecular theory in just a bit. Let's not get too excited. But this is a solid. So would you say this is more orderly or less orderly than, for example, a liquid or a gas? Which of these three is more in order? It's going to be the solid, right? So for part A, we know that delta S is going to be less than zero. And that is because it is decreasing in disorder. Remember that entropy is a measurement of disorder or randomness, or rather the tendency for energy to spread out. So when it's in a solid, less of that energy is going to spread out. So that will be our answer for part A. Now, let's do part B. Well, first, I see that gallium is in grams. So what we want to do first, we want to know the molar ratio. So gallium has a mass of 69.723 grams per mole. The freezing point was also given to us. It's going to be 29.8 degrees Celsius. So let's convert this into Kelvin really quick. 29.8 plus 273.15, that gives us the temperature, which is 302.95 Kelvin. Okay. And it's asking us to find it when it solidifies at the given freezing point. So we have these two. So we must remember our equation for delta S is equal to Q over T. Now, to find Q is going to be equal to the mass of our gallium in grams, 60.0 grams, and we have to convert this into moles. So we say 1 mole over 69.723 grams of gallium. And next what we have to do is we have to use our delta HF, because our Q, we want to convert this into joules. And the reason why is because remember that Q is a measurement of heat, and we want that in joules. So we have joules per Kelvin. So now, our delta HF is given to us, but how can we use it? Well, similarly to the problem we did beforehand, we can simply plug it in. But there's a thing about the sign. Do we want it to be positive or negative? Well, since it's freezing, it's going from a more disordered state into a more orderly state, which is a solid. So we know that our delta HF is going to be negative. So we have negative 5.59 kilojoules per mole. And next, to convert this into joules, well, we just multiply by 1,000. 1,000 joules per kilojoule. Okay, so from this, we get that Q is going to be equal to 60 times 1, I do not want to go there, 1 over 69.723 multiplied by negative 5.59 multiplied by 1,000. So we get that our Q is equal to negative 4,810.46 joules per Kelvin. To simplify this, we get negative 4 point, what are our sig figs? We have 3 significant figures, so we have negative 4.81 times 10 cubed joules per Kelvin. We could also simplify this into kilojoules, but we'll see what we have to do first. And now we have to find the delta S. So we can use this value here. So we obtain that our delta S is going to be equal to negative 4.81 times 10 cubed joules per Kelvin over our freezing point, which is 302.95 Kelvin. Now, let's see what we obtain. We obtain that our delta S is equal to negative 15.87 joules per Kelvin. Rounded to 3 significant figures, negative 15.9 joules per Kelvin. And this makes sense. Our initial prediction was right. Our delta S is going to be less than 0 because we're going from presumably a solid, presumably a liquid, into a solid. And that is going to be the change in entropy. It's going to be negative because we're going from a more disorderly state, that being a liquid or a gas, and we're going into a more ordered molecular state, being a solid. So overall, we're going to have a decrease in entropy. And that will be all for this section. If you would like more practice problems, just let me know, and I'll be more than happy to help.